So we're going to have a look at some questions on straight lines and nth term rules. So question 1 says complete the table of values for y equals 3x plus 1, and that's the thing to look at because that's telling us what to do to turn x, which is here, into y, which is here. So it's telling us how to turn the top row into the bottom row. And pretty much 3x means 3 times x, so we're timesing by 3 and then we're adding 1. And when we do this, it's a good idea not to start at this end of the table where the negative numbers are, but at the positive end. So we do 2 times 3, which is 6, add 1, which is 7, and that goes there. Now we do 1. 1 times 3 is 3, add 1 is 4. Now this one. 0 times 3 is 0, add 1 is 1. And what you'll notice is it's going down in threes, which means that this is minus 5. Because I've just gone 3 down from minus 2. So you don't even have to work it out for the negative ones. Now, once you've worked them out, what you've got here are a bunch of coordinates. So the first one is minus 3, minus 8, and then minus 2, minus 5, and so on. And that's how you turn it into a line. And then we've got 2, 7. So all we're going to do is plot them. So now you can see here, the first thing I'm doing is I'm looking at my scales. So this scale is nice and obvious, 1, 2, 3, 4, 5 and so on. The horizontal scale is a bit trickier because look, it's 2 squares for every 1, and there is also a mistake on it because this 2 should clearly be here because that would make it even gaps. Now there won't be a mistake on your exam paper, this is just one that has come through the mill, so to speak, hasn't come out very well, so there wouldn't be a mistake on your exam paper. Do look very carefully at these. So 2, 7, 2 along, it's not here, that's 1 along, 2 along is here, 7 up is there, so 2 along, 7 up. Then this one, 1 along, 4 up, that's there. So we've done 2 along, 7 up, we've done 1 along, 4 up, 0 along, 1 up. There we go. Minus 1 along, 2 down. And what you'll notice is there's a pattern here. It goes down 3 along 2, down 3 along 2, down 3 along 2, down 3 along 2, and you can save yourself all the hassle of getting your plotting points wrong just by noticing the pattern. Now if you want both marks, you need to get your ruler out. Unfortunately I don't have a ruler on this bit of software, and draw yourself a nice straight line all the way through the points. Alright, question 2. So we've got some patterns here made from sticks. How boring. Why couldn't they be made for something interesting? Like caterpillars or something. Anyway, pattern 1, pattern 2, pattern 3, complete pattern number 4. Okay, well that's pretty straightforward because there just needs to be a fourth one of these amazingly artistic patterns. There we go, that's a mark. Complete the table. You cannot get this stuff wrong. Look at the number 3, count on your fingers, 4, 5, 6, that's adding 3. 7, 8, 9, adding 3. 10, 11, 12. 13, 14, 15. So that's 2 marks. Now, Jenny wants to find the number of sticks in pattern number 100. So there's several ways you could do this. There's several wrong ways. So be very, very careful. What you need to notice is you need to notice what times table it is. And it's the 3 times table. And you can see if you times the top number by 3, you get the bottom number. So she could just do 100, so the pattern number, and she could times it by 3. So 100 times 3, which is 300. And if you come up with a rule, because people do very reasonably, people are very good at spotting cunning rules, but if you do, check it to see it works, because if it doesn't work on these numbers, it's not going to work on 100. So I've said my rule is pattern number times 3, and I'm going to try it out. So 1 times 3 is 3. Okay, that's good. Let's try over here. 4 times 3 is 12. Okay, my rule works. Often people think there's rules that don't work. For example, they might think that pattern number 10 is double pattern number 5. It's not, and you can even check that, because look, pattern number 2 and pattern number 4, well actually it is in this one, but very often it's not. So do check. So you can see here pattern number 4 is double pattern number 2, so you probably get away with it. Question 3. The nth term of a number sequence is n squared add 1. Write down the first 3 terms. So term number 1, term number 2, and term number 3. So n squared add 1. So we take 1, and we go 1 squared, and we add 1 to it. 1 squared is 1, add 1 gets you to 2, so that's our first number. Second number, 2 squared add 1. So 2 squared is 4, add 1 is 5, that's the second number. The third number, 3 squared add 1. 3 squared is 9, add 1 is 10, that's the third number. So there's my 2 marks. Notice what I've done. I've taken this thing here, and for the first number I put 1 in instead of n. For the second number I put 2 in instead of n. For the third number I put 3 in instead of n. And if I wanted to work out the 100th number, I would have put 100 in instead of n. Right, the challenge question. So the nth term of a sequence is n squared add 4, and Alex says the nth term of a sequence is always a prime number when n is an odd number. Alex is wrong. Give an example. So I'm just going to try some odd numbers, because I'm going to prove him wrong, and the way I'm going to prove him wrong is by finding an odd number where it doesn't give a prime number. So let's see. So we've got 1. So 1 squared add 4, that's 5, so that's prime. So that doesn't prove him wrong. 3. 3 squared add 4. So 3 squared is 9, add 4 is 13, that's prime. So 3 doesn't prove him wrong. How about 5? 5 squared add 4. That's 25 add 4, that's 29. So that's prime as well. Looking good for Alex. 6, how about 7? 7 squared add 4. 7 7s are 49. 49 add 4 is 53. 53. That sounds like it's prime. At this point, you might not be so sure, so you might put your question mark there to come back to. About 8, 9. 9 is an odd number, isn't it? So 9. 9 squared plus 4. 9 squared is 81. Add 4 is 85. And that's not prime. There's no doubt about that, because it's in the 5 times table. So Alex is wrong. Poor Alex.